Today we have 16.2 integration of trigonometric functions. Just a very quick recap of what we have learned recently over here. Okay, remember that if you have y equals to sine x, therefore when you differentiate y with respect to x, what you have is cosine x. So the logic is, if you differentiate sine x, you get, with respect to x, you get cosine x. So therefore, if you integrate cosine x, it becomes sine x. Okay, the next one's slightly trickier. If y is equals to cosine x, so if you differentiate y with respect to x, you get negative sine x. So, okay, it goes to follow that if you integrate negative sine x, you get positive cosine x. Or the other way of thinking about it is, if you integrate negative sine x, you get positive cosine x. So it goes to follow that if you integrate sine x without the negative with respect to x, what you should get is negative cosine x. Okay, last one is if you differentiate, okay, if you have y equals to tangent x, differentiating this with respect to x, you get secant square x. So if you integrate secant square x, you get tangent x itself. Over here, tangent x differentiated is secant square x, integrated, you get tangent x. Okay, so far, the only one that you need to be mindful of is when you integrate sine x, you get negative cosine x. Or because of when you differentiate cosine x, you get negative sine x. Okay, now let's just move on to a couple of examples. So if we take a look here, we are doing part A now. You're integrating pi over 2 plus sine x with respect to x. So pi over 2 itself is a constant. So if you're integrating, you get pi over 2, you just add the x there. Cosine x, you remember, is something special. It will give you negative of cosine x. Don't forget your integration constant plus c. And you are done. Alright, okay, for the next one, what we have here is this. I think we will need to actually simplify first. So integral of 4 plus 2 cosine square x over 3 cosine square x with respect to x. Okay, now see here, alright, you need to remember this. So first, I will break up the fraction into 4 over 3 cosine square x plus 2 cosine square x over 3 cosine square x. What you get is 2/3 with respect to x. Okay, now what is 1 over cosine square x? If you remember, okay, 1 over cosine x is secant x, the third letter c, secant x. So similarly, 1 over cos square x is secant square x. So you need to be able to apply this identity in order to simplify this term over here. So if we have done that, what I get is 4 over 3 secant square x plus 2/3 with respect to x. Now all the stars are aligned. Okay, if I just integrate, secant square x integrated will give you tangent x. 2/3 is a constant, so if you integrate, you get 2/3 x, and don't forget your integration constant plus c. So, and that is that for part B. Okay, now if you can, please pause the video and attempt try 9. When you're ready, unpause the video and I will go through try 9 with you. Okay, for part A, if you integrate x, okay, if you remember your basic integration, so you have power plus 1 divided by the new power, hence you get half x squared here. Sine x integrated gives you negative cosine x. Don't forget your integration constant plus c. Now, pi is a constant, so when you integrate pi with respect to x, you get pi multiplied to x. Cosine x, okay, you integrate is sine x. No change in the symbol here, so you still stick with negative of sine x. Once again, the integration constant plus c. Last one needs a bit of a manipulation. So what we have here is integration of 2x cos square x over cosine square x minus 1 over cosine square x. Cosine square x and cosine square x will eliminate to simply leave you with 2x. here, this will give you 1 over cosine square x is secant square x, which is shown here. So integrating 2x, so it's 2x squared divided by 2, eliminate the 2, secant square x integrated will give you tangent x. And this is it for try 9. Okay, now, what this whole page is talking about is this. So I just give you an example. If y is equals to sine of 2x, if we differentiate y with respect to x, sine 2x becomes cosine 2x. Then you still have to differentiate the 2x for the 2, okay, and then you multiply by the 2. So what happens here is this: if I'm integrating 2 cosine 2x with respect to x from here, what happens here is the cosine 2x integrated with respect to x is just sine 2x. Here is still a 2. You still need to differentiate the 2x and divide the entire thing by 2. So 2 over 2, you get sine 2x plus c. Okay, so you need to differentiate and divide by what you have differentiated in order for you to get when you do the integration itself. Okay, I think this will become clearer for you if I show you a few examples. Example 10. Find the following indefinite integrals. So part A, integrate sine 2x with respect to x. Sine 2x, remember, what you get is negative cosine of 2x. Then you need to differentiate the 2x to give you 2. Then you must divide everything by 2. Hence, you get negative half of cos 2x, not forgetting the integration constant plus c. Okay, for part B itself, okay, for part B, what we have here is this. First and foremost, sine integrated will give you negative cosine. So what we get is negative 2, okay, cosine of 5x plus pi. Then we need to differentiate 5x plus pi differentiated with respect to x gives you 5. Pi will just become 0. So you need to divide by 5. So it's negative 2/5 cosine 5x plus pi plus c. Okay, next one, part C. Secant square x. If you integrate secant square x, what you get is tangent of 3x plus 5. Then, not forgetting, you differentiate 3x plus 5 and you divide. So you put a 1/3 here. Hence, I get 1 over 3 tangent 3x plus 5. Not forgetting, plus c, integration constant. Now, last but not least, okay, tangent square. You are not able to integrate tangent square at the moment. So one of the ways to do this is to remember an identity. So if you remember this identity from trigonometry itself, that we know that tangent square theta is equals to secant square theta minus 1. Okay, this is from trigonometry itself. So what we can do here is to simplify. So what I get is secant square 2x plus 5 pi minus 1 with respect to x. So secant square, okay, integrated gives you tangent of 2x plus 5 pi. Then don't forget to differentiate and divide. So here what we get is half. Then negative 1 integrated gives you negative x. Not forgetting our integration constant plus c. That's it for example 10. Now, please do pause the video, and when you're ready, unpause the video to try for the answers to try 10 itself. Okay, first one is this. If you integrate cosine, what you get is a sine. Okay, then you differentiate the brackets. Okay, 2x plus pi over 3, you get 2. So you put 1 divided by this 2. So you get half sine 2x plus pi over 3 plus c. Okay, for B, secant square integrated, it gives you tangent 2x. Then you differentiate 2x and you divide by what you have differentiated, which is 2. So it's half tangent 2x plus c. For C, if you integrate, okay, the constant 3 integrated will give you 3x. Sine, you integrate is negative cosine, so negative and this negative will interact to give you a positive. So it's cosine of half x. Half x differentiated gives you half. So what you do is you divide by half, then 1 over half. 1 over half gives you 2. That's why here you get a 2 cosine half x plus c. Part D, 3 cosine of 4x minus 1. So same thing, cosine integrated gives you sine of 4x. You differentiate the 4x, you get 4. So it's 3 divided by the 4 over here. Then negative 1 integrated is negative x. And don't forget your integration constant plus c. Okay, now I will move on to example 11. Okay, so for example 11 itself, find this differential. Okay, now if you remember u times v, what do we need to do? Yes, we need to use the product rule. Okay, so now very simply I will apply the product rule itself. U is x, you differentiate u with respect to x, you get 1. V is sine x, differentiate v with respect to x is cosine x. So if I differentiate x sine x, what we get is v times du dx is 1 plus u times dv dx. Okay, now what they want me to do is to integrate x cosine x. Notice the word here, hence. So when there's the word hence, you need to use the result they've gotten from the previous part of the question itself. So, okay, going by this logic, if you differentiate x sine x, you get this. So therefore, if you integrate these two terms, you would get back x sine x itself. So how do we write this down? So what I will say is, if I integrate, okay, sine x plus x cosine x with respect to x, what I will aim to get is x sine x plus c. Okay, so far? So if I do that, notice that what they wanted from me is just the integral of x cosine x. So what I can do is to start to split up the left hand side. So I have integral of x sine x plus the integral of x cosine x dx. Not doing anything special, I'm just splitting these into two guys here. Okay, is equals to x sine x plus c. Now what I'm going to attempt to do here is to integrate x cosine x with respect to x, which is this guy over here. Then I will move the integral of sine x over to my right hand side. So I get negative integral of sine x with respect to x plus x sine x plus c. Notice that I have aligned what I need to do, so I just need to integrate. So this is what I'm trying to find. This is the equivalence on the right hand side. So now integrating sine x gives you negative cosine x. So negative cosine x, negative and negative, you will get positive. So what I get is positive cosine of x. Okay, so integrating this, you get positive. No need to add another plus c. There's already one plus c here to take care of all the constants already. So no need the integration constant here. Then I keep my x sine x plus c. And my question, example 11, is done. Now it's your turn to try 11. Please pause the video, try it. And once you're done, you may unpause the video and we will carry on. Okay, now applying the product rule, if u is equals to x, du dx is 1. If v is cosine x, dv dx is equals to negative sine of x. Hence, applying the product rule will give you cosine x minus x of sine x. Now, same thing, okay, what we do here is this. if I integrate, okay, negative x sine x plus cosine x, what I should get is x cosine x. So what I do here is I will rearrange my terms, so I just get x of cosine x. It becomes negative the integral of x sine x dx plus the integral of cosine x. So I'm just splitting this thing up like what I did in my question itself. So what I get is the integral of x sine x equals to cosine x, the integral of cosine x minus x cosine x. You integrate cosine x, you get sine x minus x cosine x plus c.